right in the middle. And it is. Yep. Perfect. Exactly where I want it. Yep. Now, what I want to do is I want to get the actual cone in the actual image. The finder is off by just a little bit. Over time, what happens is the screws become a little loose. So, the actual center point of the actual telescopes are actually right above that second circle. And a little bit to the left, unfortunately. I think I gotta go over just a little bit more. Right about there. And I should be able to get both of them right in view. Let me see. That center star there. Those 3 stars there. Just a quick 47-second exposure just to see where we are. I think that's... I'm pretty sure that that's it. What it looks like here. I'm probably going to have to change the histogram here because 1/10 of the image of what it's supposed to look like. This is definitely it. Perfect. Okay. Yeah, we're good. All right, cool. All right, awesome. So then we'll start it. How's guiding? 0.51. Perfect. Let's do it. All right. So now we're guiding. We're gonna see if we can get this for a little bit, and then we'll shoot the comet. Then we'll go after 38p. I probably could have moved it down a little bit more. I should have done that. Oops. Hey, you know, I could always do a 2 or 3 night session. You know, I could always get that, you know, get an hour, and then come back and get another hour, and come back and just keep doing it. You could definitely see some dark lanes and stuff. It looks really, really cool. I won't get that. now without a monochrome camera, I won't be able to get that. For how big it is, I can tell you right now. The middle of the Christmas tree cluster is this bright star that you see right here. That's the middle of it. Where the actual cone nebula is going to sit, it's going to be right here. So the whole thing is going to be this right here. So you're going to see all of this. So it's these 2 bright stars right here is practically going to be the entire Christmas tree cluster and the cone nebula. Now, of course, there's more rich, dense, you know, a whole bunch of stuff to the left all throughout here. I won't be able to get any of this. Maybe, like Jurgen said, there is going to be a lot of dark nebula and everything, like very faint all throughout this region here. So the actual cone nebula itself, you might be able to pick it up here because it's a 3.9 magnitude, and this is going to be really bright because you can actually see some of it even with a 24-second exposure. You can see some of it through here. But all the faint stuff, you won't really pick up much. And with a 12-minute exposure, I might be able to get it in stacking and processing. It'll be tough. But I can try to see if I can pull stuff out of this. I did the Cave Nebula 2 years ago, and that was another one that was a challenge. And I was doing 2,400-second exposures. And I was getting just enough detail. Not a lot, but just enough detail. 40-minute exposures, and I was getting just enough. Well, this is going to be done in 3 seconds, so we're going to see what this looks like. Alright, let me zoom out here. Where is this oriented? Let's see here. oriented this way. Oh yeah, okay. Yep, there it is right there. That's the cone right here. This little thing right here is the cone. And then this is the bright star in it, and then all of this is going to be the Christmas tree cluster here. So it's there. You can see it. It's there. It's not exactly great. It actually turned out pretty decent. I was going through some of the older sessions too, and then eventually I'll go back and then I'll, you know, do the newer ones and the older ones. There we go. Okay. See if I can zoom in here. Yep, the cone's right there. It's not fantastic, but it's there. There we go. So they're oriented the wrong way, but you get the idea of where it's supposed to be. So on the left-hand side, the left camera, this is the bright star in the middle of the Christmas tree cluster, and the cone sits right here. And then this is all going to be nebulosity all through here. Now, of course, this is zoomed in at 225%. And the camera on the right, again, this middle one is the bright star there. And then the cone nebula sits right here. So this is gonna be all somewhat a little bit of detail, but it's not gonna be a ton, but you're gonna definitely see it. And the reason why this is called the Christmas tree cluster is because you can see how it comes to a point with the bright star, and then it comes this way and then goes around, so it's kind of like ornaments on a tree, pretty much. And then the cone sits that's pointing towards it. And of course, all the way on the left here, you're going to see there's going to be some faint detail over on the left, but with stacking and everything, I don't think I'm going to be able to pull out anything. I do not upload them on Instagram. I do this as a hobby. I don't do this professionally. I do this just solely just as for fun. I love to do this. I've been doing this for about 6.5 years. It'll be 7 years in May. I've been doing this since 2012. The 46p, or the 46p, I actually just posted the were canon. I posted those on my YouTube channel. I did a time lapse. I did a whole bunch of stuff with it, which was really cool. And if we have time tonight, which I know we will, because I'll get about an hour of this, and then I'll flip it to the Comet for 38p, and we'll get that. Well, if there's aliens on the moon, then I'm sure that rover, whatever it is, or lander, that was on the dark side of the moon that the Chinese put out, maybe that'll find aliens on the moon. I don't know. What I mean by different dimensions is like there's like an alternative reality. Like, this will blow people's mind, that there's an exact copy of you and Earth and everything around you on a different Earth that is just so far away and so out there that every single possibility happens. Like different copies. It's just crazy to think about that. That there really is something like that out there. Yeah, I believe that. I mean, do you believe that there used to be life on Mars that used to be like us? Maybe we are the descendants of Mars? You know, a lot of people think about that one, too. You know, that Mars was habitable at one time, and that there were so-called humans, or humanoids, on Mars. That's what I said. And that, you know, Eagle's extra rare footage, that's what I said. If they were intelligent, then they would have found us by now. But like I said before, maybe they're so intelligent and so advanced that they're trying to communicate with something that we don't even know, like dolphins. We don't understand dolphins. We don't understand how they communicate. They understand, and they make noise, but maybe it's noise to us, and maybe it's not an actual thing. We don't know. And maybe they don't want to be found. That's another thing. I mean, or maybe they're so far away that it's just with radio and light, it just hasn't gotten time to either reach them or us. Maybe they're just so far away. It's just like Justin said, and James, it's great to think about, but boy, does it makes your head hurt to think about that. It really does. And they could be here now. I mean, we're using internet. Yeah, it is getting nuts. it's getting crazy. It's getting nuts. Maybe they sent out a radio wave or whatever it is, and then it never got to us, so they said, "Ah, screw you." What about the bubble universe? I mean, that's where you connect, where they have so-called detected another like an alternative universe that is on the edge of our universe, like what they call the cold spot. It's possible. They talk with farts. That's awesome. Alright, this one should be done, so we should be able to see what this one turns out to be. So the one on the right is done. Drifted just a slight bit. How is guiding? I didn't even notice it. I didn't see it. 0.77, it's not the greatest. The new one comes out next summer, and it's with Chris Hemsworth, who played Thor for the Avengers, and the girl, I don't know her, the girl who was with Thor in Ragnarok. She was the Valkyrie. Both of them are in the next movie. A plane just went through. Yep. A plane just went through the image. Are you kidding me? Oh no, that might be a satellite. Let's take a look and see. Maybe it was a satellite. And it was. The satellite that came through was... And I'm going to put it on here so that way everybody can see it. I don't know if you can see it on the actual screen. I'm going to make it bigger so this way you can really see it. There we go. Can you see the line that's going up and down? Pretty sure you can see it, right? I think so. And we're going to put a text. Yes. Oh, shoot. I lost it. There it is. Okay. So that's the satellite there. And its visual magnitude is 13, so it's fairly faint. Its distance is 37,000 kilometers above Earth. Its velocity is 3 kilometers per second. This thing is trucking. And it is appearing in the constellation Monoceros. It orbits Earth every 24 hours. There you go. So we got a satellite. How cool is that? And it's going to appear on the other one, too, on the red one. So you're going to see two of them. You're going to see on both of them. I want to be the first man to take a dump on Mars. Define a magnitude of 0.00. Well, 0.00 is pretty much even. The sun is negative 27, and something extremely dim. Oh, that was the plane that there's a. Oh no, there's a plane that went through. Oh snap! Of course, Pluto is like 13th magnitude. So 0 magnitude would be something like Vega. Vega's 0. Sirius or Sirius, which is a star, that's one of the brightest stars in the northern hemisphere sky. That's negative 1.4. The bright star that you see there in the cone, that's 15 Monoceros, and that's a fairly bright star. It's not naked eye star, but it is fairly bright. That one is a 4.7 magnitude star, so in very dark skies, you might be able to pick it out with your naked eye. Might. But you'd have to have very, very, very dark skies to do it. So, negative is super, super, super bright. So, like the sun is negative 27. That's the brightest thing that we can see. Well, I wouldn't really see it because you burn your eyes. It starts to go down. Okay, so like Venus at its absolute brightest, Venus is usually negative 4 to negative 5. Jupiter's like negative 2 to negative 3. Vega is 0. And then you start to get dimmer. Okay? So, like, these stars, like the stars that are near the Cone Nebula, like that bright star that you see, I'll point it out here. And then, of course, you get dimmer and dimmer and dimmer. Yeah, that went right through. Oh, look, it actually started halfway through the image. How cool is... Oh, wait, is that a... Oh, that's the plane. Oh, oh, no. Oh, no, you got planes and you got satellites and you got everything going through this thing. Ah! So the satellite was right here. So this was the satellite, and then the bottom one was the plane. Oh, that's terrible. Went right through it. It does. Okay, cool. So that bright star at the top left on the Canon camera, like I said before, that one is between... Now it varies, and that's another thing too. It varies. It varies between 4.67 and 7.79. So it goes up and down in brightness. So sometimes it can be very, very bright, and sometimes it can be very, very dim. The absolute magnitude of this is negative 2.58, which means if you were so close to it, that would be the brightness of it. The luminosity, which is another thing that we use, and the luminosity is 1 lumen is the sun. Okay? 911 is the brightness, is the luminosity of that star up at the top left on the Canon camera. Well, let me get rid of that, because that satellite's gone. Well, I could probably move it, because it's... Right, exactly. Variable... That's what the word I was looking for. It goes up and down. Variable. Thank you. I knew it. I knew the word. Right. 2.54. Right. You captured a Soviet satellite, Cosmos 1936. Well, that's cool. "10 parsecs. Okay. I wasn't sure what the actual, like, how far you had to be. I wasn't sure. It's cold outside. Well, how cold is cold, Justin? How cold? Can you see your breath? That's the thing. It's probably that cold. Well, that was a dumb question because you're smoking. probably is pretty cool. Zoom out a little bit here. Nice. And there's the plane. Ha! There's the plane right there. So that's 2 images on this one that got ruined due to a friggin' plane and a satellite. You gotta be kidding me. What do you mean by a tumbler? Oh, you mean these two lines here? That was probably from that dumb plane. Yeah, because you could tell. Oh yeah, yeah, that's these 2 things right here. (30°C). That's... in Fahrenheit, that's 86. That's hot. Hot. That's because you're in summer. Yeah, that's pretty cool how it does that. And Mark, it was really cool to see it on the Finder too, because that thing just whipped right through. And I remember I did a stream earlier this year, and I was doing it on Starry Night and actually watched the sky, and I hit, fast forward, and the sky goes backwards, which is crazy. It goes the opposite direction because it's in the south. We have taken... how many? This is number 4. Let's see what the stars are going to do here. Let's see. Oh, perfect. It barely moved. And the satellite is gone. So is the plane. Which means we got to get rid of that. Bye-bye. Yes, you want to remove the text? Yes. Bye-bye. Tarantula. He's in jail now. Well, that's good. That is good that he's in jail now. That's great. Deservingly so. Kidney punched by a kangaroo. That's awesome. Nebula. That would be so amazing. And to get that, like if you were to do that from a dark sky site, I mean, just to think about that would be incredible. And wide field too on top of that, that would be epic. What the stars do? Good, they barely moved. Excellent. I'm on number 5 right now for this one. So I'm going to probably take one more on each. I'll take one more, and then we'll flip it to the comet. Let's see if I can get it. I'm hoping I can. When that image is done, over on the right. Let's see what it does. That barely moves. That's great. Alright, so we're going to stop that. Okay. Okay. And while we wait for this last image to finish, I want to see exactly where we are in the sky. So this way I know where we gotta go. Okay, so the comet is moving further away from Castor and Pollux and getting closer